My name is Marco, and I present you a small project I've been working on in the last month. The idea is to um, build a layer on top of Python Pandas, which I spend a few words to describe you what it is for those who don't know. Pandas is a Python library for making data analysis. It's, of course, written in Python slash, oops, too early. uh, and is based on NumPy, and it is inspired on R. R is very popular, quite popular language to make data analysis, and the problem with R is that is very specific. So Python Pandas is a library to have a more general purpose language to work with. It's very inspired on R. The main data structure is the data frame, which is basically a heterogeneous matrix by the data type point of view. You can hold different data types in different columns. And Pandas introduced some improvements to the data frame, which is multiple level indexes, and some optimization when working with time series. There are many pros in using Pandas. Good performance, because critical code is written in C, so it's very fast when making merge operation, group by operation, and of course all the numerical function. It has intelligent data alignment because different columns are actually held in different matrices. Each one has its own data type, and so the alignment is kept consistent. But it's still quite hard to explain to someone who's not a computer scientist, someone who has not a computer science background, how to efficiently work with such a tool. So this is a small vicious cycle that is I found myself in. Those that are interested in making data analysis usually don't know what to do, don't know how to make data analysis. And these are journalists, company managers, and such. So they ask statisticians to make that analysis, but statisticians usually don't have the right tools to do so. And they have to ask computer scientists to help them. If the communication fails, this is the result. Good analysis, but which was the question? It actually happened to me. So the goal was to build a layer on top of Pandas to make things easier and to make things more scalable and reproducible. What do we have to do? We have to define which columns in a data frames should be used as dimensions. Which columns are calculated from other columns, and introduce do what I mean behavior in some function, specifically in merging operations and in aggregating operation, which we call rollup. Then there are some statistical functions mainly used with time series that are quite always the same, even though they are quite complex to implement to someone who has not a computer science background. And finally, there is no need of a data analysis if we cannot produce some reports of it, if we cannot present the result in a human readable way. So, the project consists basically in a metadata structure around the Pandas data frame. This metadata describes what I just said, so gives a role of, to each column of a data frame, and an engine try to find out what to exactly the user wants to do with this data. So this is the basic first step to use star. With pandas, I can load the data from many different type of files or database. This is just one case from a CSV file. Then I put my data frame inside the star object, and the star framework adds a default metadata, or I can pass a metadata structure that I have built before. This metadata is basically is built with Python dictionaries. And in this dictionary, I describe type of columns, so dimensions, which can be used, and Python indexes, but the user don't know anything about this. So the system just define the indexes when it's the right time to do it. Numeric column, well, that's quite obvious. Immutable values are labels or other values that are always the same for a specific dimension. And finally, elaboration. Elaborations are columns that are calculated like as function of other columns. And when I do further elaboration on raw data, these must not be messed up. So they should be reevaluated when the original data changes. This is just a basic idea behind dimensions. It's a typical star structure in which data are in the center, and dimensions, definitions, and levels are linked together in a star shape. Typically, this is used for aggregation operation and to change level. The typical case is city, country, and region, which can be easily switched with just one function call. Elaboration in pandas, as I said, a new column can be defined as a function of other columns. This is just a basic example. And with star, the same thing is defined with a slightly different syntax, which tell the system how the column should be reevaluated every time the original values changes, or when I do aggregation that that uses these values. And finally, there is a small reporting engine. This reporting engine lets you define templates in LaTeX or HTML. We leave in placeholders for data representation. Data can be represented in tabular form or graph. And there is the project to build an automatic stacks generator. Graphs particularly are interesting because I tried to leave space to build more modules based on matplotlib and build different type of graphs. By now there are just simple type of graphs like simple plots, bar graphs, and scatter, but more can be added quite easily if you know matplotlib API. This is the basic usage. You call a Python script, start reporting engine, calling a folder containing both the template in LaTeX or HTML and data in form of Python pickles. So you save your objects, your star object as Python pickle in a folder, and you can easily produce a report. Or if you want to produce multiple reports with different data set, but always the same template, you can just accessing API of this star reporting engine. What I want to do from here? First of all, as I said, the automated text generator should be implemented maybe using scikit-learn or some other machine learning tools. I actually don't know. More plotters, much more plotters. Evaluated record handling, which is quite the same thing that evaluated columns, but should work on records instead of columns. And maybe integrated with stat model to let define statistical models to apply to the data. And that's pretty much it. Thank you very much for listening. If there is any question?
You said right at the end that future changes could include automated text generation. I don't really understand what you meant by that.
The idea is something to analyze data and produce a descriptive text of it, a short descriptive text of it. Actually, by now, there is a small feature that does this, but it just says it's, you define a range, some ranges, and it tells back if data are in a good range, in a medium range, or in a low range. That's it. Anything else? Okay, thank you.